Welcome to another session of databases. Today we are going to look at the details of normalization from un-normalized form to third normal form. And if you just recall, we last session we looked at the concept of normalization and the main challenge of duplication and redundancy. So today we are going to look at the un-normalized form, un-normalized data, the characteristic of un-normalized data, and then three main steps or three basic forms that we have to work on to achieve normalization. So if you just recall, we mentioned minimizing or reducing data redundancy and improve data integrity. These two concepts are linked together. So when we are reducing data redundancy, technically we improve data integrity. Okay, so we cannot actually eliminate or remove duplication. We will have duplication sometimes, redundancy, and specifically on some attributes, but this is the way that we are going to work. And this is the second part of the definition of normalization, and as you can see, it mentioned that entails organizing the columns, which are attributes, and tables, which is technically relations of a database, to ensure that their dependencies are properly enforced by database integrity constraints. It's accomplished by applying some formal rules, either by a process of synthesis, creating a new database design, or decomposition. It means improving an existing database design. If you recall, in last session we talked about a table, and then ultimately we split that table into two new tables. Okay, we technically decomposed or synthesized the old table into two new tables. And this is a kind of applying some rules or systematic way for normalizing data. So we are going to look at un-normalized form. We're going to see what is the characteristic of an un-normalized form. This is a template of normalization. As you can see, we are starting our design by looking at un-normalized form, and then first normal form, the next step, or applying some rules on un-normalized form, we will get first normalized form, and then again by considering and checking something, we achieve second normal form, and then from second normal form to third normal form. So we expect that third normal form would be can provide us good normalization and with less duplication, less redundancy. Okay. So as you can see here from UNF, list of un-normalized attributes, which perhaps there are some keys, the chosen key field, and there would be some repeating groups. We will look at the details in a minute. Then first NMF, this attribute is split into separate data groups, having broken out repeated groups. Specifically in the first normal form, we will have and we will identify the primary keys or primary keys, and any foreign key. Again, I will explain this concept as well. And then we will go for the second normal form by again, as you can see, again, splitting these data groups by considering some characteristic of dependency of attributes and then achieving third normal form. So we're going to actually look at this in detail and see how these forms can be achieved. So starting from un-normalized form, so the characteristic of un-normalized form, as you can see from this slide, is going to be with these four main elements. Data may be repeated, data may be non-atomic, the concept of atomic or single value. Atomic means the data is the lowest level of lowest possible level and cannot be decomposed into more details. So, and also data may not have a primary key. There is no primary key in un-normalized form. And importantly, in un-normalized form, we have repeating fields or multiple attributes or columns with the same data. So wherever you can see these type of characteristic, you will say that this is un-normalized form, and you have to recognize all of these stages, all of these forms. So let's look at this example. We have a student registration form, and with these different attributes, we have a student number, a student name, forename, gender, address, as well as module code, module title, lecturer code, and lecturers. Okay, we have all of these fields as a registration form. And then for one instance of this form, you can see student number 1 to 6, Smith Joe, male, address 23 Newcastle Road, Belfast, and this student enrolled in 4 modules, and each module has module title, for instance, CSC 1, 2, 3, 4, computers are awesome, lecturer code 222 333, and lecturer Dr. Ball. Okay, so we have here some repeating data. We have a student name, student information here as well. So let's assume we have 500 students, okay, in a system with 500 students, and this is the first step of looking at a student registration date. So we aim at working on this registration form and providing a way to systematically define some rules and achieving first, second, and third normal form. So in this case, we need to have a notation. We call it a schema notation, a standard notation for documenting the entity names, attributes, and identifiers. So the notation which you will use, and you get used to have this kind of notation in your practical as well as exam, would be something like this. Notation would be entity, and then square brackets, you can use attributes. You use underline for the primary key attribute, and also for the repeating fields, you can use a parenthesis or normal brackets. Okay, so there would be some more details in notation, and you will gradually actually learn all of this. So, for instance, for the case that you saw for the student registration form, we can illustrate this notation, this schema, using this line of notation or description, registration, and then square bracket, a student number, which is a primary key, so it's going to be underlined with underline markers, surname, forename, address, gender, and then we have a set of repeating fields which would be in the parentheses in the last part. Okay, so this is a type of representing unnormalized form for this registration form. Okay. So, and if I ask you what is the notation, a schema notation for this form, you will write exactly this way. Registration, student number, surname, phoneme, gender, and then parentheses, module code, module title, lecturer code, and lecturer. The last part is the repeating field, and it is the first element, primary key with underline and in bracket, and the entity name. Okay? So now we have this registration form, and if we go for the designing table with this unnormalized characteristic, it's going to be a huge amount of space and the issues that we discussed. So in that case, we are going to more evaluation of this form. So the first normalization form has this rule. As you can see, there are no attributes with repeated or similar data. So we're going to actually move from un-normalized form to first normal form by considering these rules. And we say that for first normal form, we have no any attributes with repeated or similar data. Each attribute cannot be broken down into any further atomic that we need. So each instance of entity is unique. It means we have definitely a primary key, and also each attribute has a unique name. Okay, these are 4 rules to have a first normal form from un-normalized form. So in terms of the atomic, there are some kind of explanation and also maybe ambiguity in the definition, and also belonging to which type of normalization, because we have, for instance, if you look at the references in databases, we have 4th normal form as well. Some people, actually some authors, consider this being single value in a 4th normal form, etc. So, but for our case in this module, we are going to as we need and not much far away our expectation with learning outcome of this module. So here you can see some kind of summarizing this unnormalized form description and a schema, and then moving from unnormalized to first normal form schema. So as you can see here, we have list of unnormalized, and we have a notation now, a schema notation that we can represent this part, which is a student number and etc. So from UNF to first NMF, what we are going to do is splitting this attribute into data groups, having broken out repeated groups. It means the first actually things that you do, check groups, repeated versus non-repeated attributes, and identify keys, compound or foreign key for each. Okay, so this is the key point for moving from unnormalized form to first normal form. Check groups, repeated versus non-repeated attributes, and identify keys, compound or foreign key for each group. So, for instance, if you look at the first normal form, these attributes are split into two groups: the student number, surname, forename, address, gender, and another group which is technically linked to the repeated group. So a student number, module code, module title, lecturer code, and lecturer. So the student number is a primary key, is here actually is a foreign key which is linked to this group or this entity, and a student number is a primary key. So foreign key technically is a key which is link matched with a primary key in another table or entity. So we split this attribute into data groups having broken out repeated groups. And we link actually these attributes, these two groups of attributes, with this student number, okay, which we called here as a foreign key. So this is the first step of normalizing, or first normal form. Identify keys of each group and any foreign key, and using @ demonstrating of foreign key. Key of repeated group will be compound of at least two attributes. Okay, so this is just a definition of foreign key. We say an attribute, or could be a set of attributes within one relation that matches the candidate key or primary key of other entity. So in that case, we will have this group which is linked with the student entity, and another group which is related to the enrollment entity, and specifically for the repeated groups of attributes. What is really important is considering this point: a student number in enrollment is a foreign key or FK to a student number in a student. This means that any student being added to enrollment must first exist in a student. Okay, that's technically known as enforcing referential integrity. And we, as I said, we use @ for indicating a foreign key. So now we moved from unnormalized form to first normal form. So now we're going to go for the second normal form. So the rules for the second normal form is we already achieved first normal form. We are in the stage of first normal form. Then we're looking at non-key attributes. Non-key attributes must depend on every part of the primary key. So in second normal form, the rule from first normal form to second is we're going to check the dependency of non-key attributes on every part of the primary key. Okay, so for instance, for this example, can you tell me which attribute is not dependent on primary key? If you look at for instance, for this one, for this part, gender, address, forename, and surname, which all are non-key attributes dependent on student number. So this is correct. So what about this part? We have two parts, primary key, which is the student number, and module code. So we are going to check if each individual non-key attribute has this dependency. And as you can expect, module title dependent on just module code. So it's not dependent on a student number. So technically we're asking, does module title require a student number? Which is no. So in that case, it means we have to do something here to satisfy the rule. So as you can see, we have first normal schema here. So this is just this is the description of second normal form. We can actually have further data groups created by having broken out part key dependencies in very simple terms. So we are going to identify keys of each group and any foreign key links. So, and if you look at the second normal form, we will have a new group with a student number and module code in a separate group, and the third group of attributes would be module code, module title, lecturer code, and lecturer. So in that case, we resolve the problem of non-dependency of non-key attributes on every part of primary key. For un-normalized form to first, we are splitting groups or these attributes, repeated versus non-repeated attributes, and also identifying keys for first normal form to second normal form. We will check the dependency of non-key attributes on every part of the primary key, and based on this, we again split the attributes. So for the third one, the rules is, again, we have to be in a stage of second normal form. The data must already be in second normal form, and there are no non-key attributes dependent on another non-key attributes. So for the third one, for first one is straightforward. You're checking the groups, repeated versus non-repeated, and identify the keys. For the second, from first to second, you check the dependency of non-key attributes on every part of the primary key. For the third one, from second to third, you check again the dependency of non-key attributes on other non-key attributes. Okay, so the difference between second, from first to second, and second to third is the second part of these sentences on dependency of non-key attribute on other non-key attributes for third. Okay, and this is really important. So now actually we're looking at again the groups that we have in second normal form. We have this part, we call this new group as in a physical design junction table, which linked these two groups of attributes. And we have, okay, we don't have any non-key attributes here, so we don't want to do anything here. For non-key attributes, dependent on other non-key attribute, if you look at this, lecturer code, and module title. So in that case, we have a lecturer as an attribute which is dependent on lecturer code. So in that case, we are going to split this group again into new group with lecturer code and lecturer. So these are remain actually unchanged, this group and the second. The third group is split into two new groups, further data groups created by breaking out non-key dependencies. So lecturer is dependent on lecturer code, and here we will have module title and lecturer code. The first one actually was a group of attributes which we received as a student registration form, and it was included two parts technically, repeated field attributes and also non-repeated. The rule for first normal form from UNF to 1NF was check groups, repeated versus non-repeated. We split these attributes into two new groups. A student number, which is this one linked to a student entity, this one linked to enrollment, and then this actually including two primary keys, one of them a foreign key which can be linked to the original and main primary key. From first to second, as you can see here, we checking for dependency of non-key attributes on every part of the primary key. So, and for this case, from first to second, we split these two, this group attributes into these two new groups. And then from second to third, again, we check the dependency, again, of non-key attributes on other non-key attributes. And this makes a new groups of attributes, the module code and lecturer code. So this is the third normal form which we usually expect to have after designing in a logical, as a conceptual and then logical design, and then we're going to go to move on for physical design and the rest of the story. And it's really hard from the beginning, from the scratch, you think about designing in a normalized form, but it's possible if you could have some practice. Perhaps you can start from this level, but this is a way of actually systematic way of normalizing this form. And in the practical session and specifically in the exam, we are going to give you some question, and you're doing this step for normalizing our tables in forms. So this would be the final schema that after third normal form we will get. A student number, surname, forename, address, gender, primary key. This is first entity. The second one, enrollment. Again, we have a student number, which is a foreign key, and module code, again, as a foreign key, which could be linked to this one. this would be perhaps module or course. Next one is course or module, module code, module title, lecture code. So again, this is a primary key. We have a foreign key again here, lecturer code, which is a foreign key and could be linked to this entity, and lecturer is the last entity with two attributes in the square brackets, and the first one is the primary key. So by writing this way, we establish a kind of standardizing our notation and normalizing all of these data. Okay. Any question? So we are going to practice all of this. Don't worry if you perhaps practicing and in a practical session help you to do this kind of thing. So the first practice, apart from practical assignment that you're going to actually do on Monday, is this one, normalize to third normal form. And again, in this module, we are going to stick to third normal form. So we have 1, 2, 3, 4, 5, 6, 7 attributes. And as you can see, we have 2 fields which is repeated versus the rest of them which are not. UNF schema notation would be something like this: pet as an entity for the whole form, pet ID, etc. So we are going to we are going to obtain the first, second, and third normal form. Okay? So we are going to work on this on Canvas. I will provide you this question on Canvas, and please be involved for answering this question.